So we've looked into doing analog output and analog input, and we used a potentiometer for the analog input. I'm sorry for the choppiness of the video and the end of that last video. My computer choked, but you got the idea. So a potentiometer is kind of like a perfect voltage divider, right? It's got an internal resistance. It's you've got power, ground, and then that center pin that's measuring like the resistance along the path, right? Not all sensors that we use, not all analog sensors that we use are going to be that sort of like perfect chef's kiss situation where we're going to get that full range of values on the analog input from 0 to 1023, 0 volts to 3.3 volts. So I'm going to show you right now another kind of sensor that you've got inside of your kit. It's called a photocell or a light-dependent resistor. It looks like, let me pull one out that I haven't stuck on my breadboard, but here it is. Sorry. It's this thing. It looks like this, right? Get it out of the way there. It looks like this, right? And you can see it's kind of like oval. It's got a couple squiggly lines on there like a snake, and it's got two legs here. So this is a kind of resistor. It's a variable resistor. So you can think of like the fixed resistors that you've got, the 330 ohms that you're using with LEDs, the 10 kilo ohm that you used with a switch. So this is a resistor that can vary the amount of resistance. So what we want to do is we want to build pretty much it's a circuit called a voltage divider. And it's actually really just the same thing that we saw before with the circuit where we had our switch with a resistor as a pull-down resistor, right? So I'm going to pull this back over here. And you can see this illustration right here. This is my photocell right here. Actually, I realized that I can do this the other day, and maybe it'll be helpful here. So, yeah, there we go. Nice big highlight, right? So this is my photocell, right? It's plugged into my breadboard. One leg goes to power. One leg goes to one of my analog inputs. I'm using analog input 7 again. And that same leg that goes into the analog input goes in parallel to ground through a 10 kilo ohm resistor. So this is our pull-down resistor again. The reason that this is here is, remember, all voltage needs to go to, all electricity needs to go to ground. You always need a reference to ground. Otherwise, electricity won't flow anywhere. So in this case, the electricity is constantly flowing across this resistor and across this resistor. Now this resistor, the amount, and so we see a voltage drop across each. What you're measuring is the dip right here on pin 7 is the difference in the voltage as it moves across from the fixed resistor. Pull up my pen. My fixed resistor right here and my variable resistor right here, right? So we're just measuring like what's the voltage right here between these two. Usually what you want to do is you want to match up these resistors values as much as possible. These LDRs are 10K total, but it's not going to be perfect. You can experiment with different resistor values here. You'll notice that if you put a smaller, like one of the 330 ohms right here, you'll see a different range and sensitivity than if you put, say, 2 or 3 10 kilo ohms in series right here. Might be worth trying to experiment with, just to see how sensitive things are and how these values might change the relationship of the sensitivity in there. Just an experiment. So what we're going to do is we're going to take that same code that we had before for getting the the value from the potentiometer and changing the brightness of our LED. And so I'm going to upload this. And what I'm going to demonstrate here is how this does not have the same range as the potentiometer. That's because it's not that perfect sort of variable resistor that I was talking about, right? This is an imperfect sensor for an imperfect world. So we can see right here, right now it's the input value is like 900-ish, right? So it's going by really quick, but it's like 907 to like 899 and change, right? And if I move my finger over it, we can see that it goes down, but it only goes down to like 500 something-ish, right? So that light's getting dimmer. I can see the values changing, but it's not like that same full range. And I'm covering this up with my finger pretty well, right? Like I'm like really, there we go. If I totally use my thumb, it's down to like 400. Maybe that brightness is more noticeable, but it's not, you know, it's not that great. If I turn the light on my camera, we can see that even then it doesn't make a huge difference in the amount of light that this gets, right? So we're never actually seeing that top range nor that bottom range. So what we want to do in order to get more resolution out of our sensors when we're using something like this, like an analog sensor, what we want to do is we want to do a little bit of calibration. And this is an adaptation of one of the examples inside of the Arduino software. I'm going to post this online. It's in the comments for y'all to look at. But if you want to find the original, you can go under File, Examples, Analog, Calibration. Or you could just go to the link below and copy it. Your choice. So I've got some constants here. One for the sensor, one for the LED. And then I've got a couple variables. One is the sensor value. So this is, we get the value that we get from our analog read. And then we've got these two others, sensor minimum and sensor maximum. You'll notice that sensor minimum is 1023, sensor max is 0. What we're going to do is we're going to do a calibration loop during our setup, and we'll loop for about 10 seconds, and we'll say, hey, if our current value is greater than the minimum, or greater than the maximum, then we've got a new maximum. If it's less than the minimum, we've got a new minimum. So that way we can set these variables accordingly throughout the rest of our sketch. I'll show that in a second. So here we open up the serial port for communication. We're just going to hang on until we're ready. And so once we open up our serial port, that's when we'll start to communicate and read the values from here. So once we open up the serial port, I'm going to say calibrating. So I'm just going to send a test message out to my serial monitor, just so I know that it's happening. And then first thing I'm going to do is I'm going to turn this LED right here, the one that pulses, that status LED that's tied to pin 13. I'm just going to turn that on while I'm calibrating. So I've got a visual cue that something's going on. That's helpful if you don't have your microcontroller hooked up to your computer. So it's just another way to reinforce this. But after I turn that on, and after I say that I'm calibrating, then I'm going to wait for 10 seconds, right? I'm not actually waiting, but for 10 seconds, right? So during the first 10 seconds of my program, while millis is less than 10,000, so millis, just like in P5.js, is a function that will return the number of milliseconds since the program began. So I'm saying while millis is less than 10,000, read the sensor, store the sensor value into this variable by doing analog read. Record the maximum. So if the current value is greater than what we have recorded as the maximum, then set our new maximum to whatever that value is. Do the same thing with the minimum. If the current value is less than the minimum, we've got a new minimum. Do that for 10 seconds, and then after this is met, we escape, we turn the LED off, and then I'm just printing some stuff out here just so I can see what's the actual minimum, what's the actual maximum. That's all. In the loop, however, we read the sensor, and then we use that map function that we were doing before to map between 0 and 1023 to 0 and 255. Here we're mapping between, we're saying sensor value, so whatever the current value is, map that between our minimum value and our maximum value, and change that to be something between 0 and 255. And then sometimes when we do this, it'll be a little bit outside of our range, and so there's this function here, Constrain, and what that does is it'll keep it within a particular range. So here I'm saying the sensor value equals whatever the sensor value is, as long as it's within somewhere in between 0 and 255. If it's below 0, put it at 0. If it's above 255, put it back at 255. So this way we don't go out of bounds for PWM or the analog write. And then we just fade the LED using this calibrated value. We just send this out. So I have uploaded this, and so what I'm going to do is I'm going to pull the serial monitor back here. And in order to get this going, I need to reset this. So I'm going to press the reset button. And after I do, we'll see this light will no longer be pulsing. It's just going to be a solid on. And then for about 10 seconds, I'm going to put my finger over this and remove it, finger over, remove it. And then afterwards, it'll print out the new minimum and maximum inside of the window. And we'll have a fuller range of values. It's going to be awesome. So press the button. Give it a second. There we go, calibrating, right? So cover it. So all I'm doing is I'm exposing it to whatever sort of like full range of information I think it might be receiving, right? So here we can see the sensor minimum is 539, the sensor maximum is 938. And as I move my finger over here, you can see it now turns off, and I pull it away and it gets bright again. And as I cover it more and more, it gets dimmer and dimmer and dimmer until it turns off. So that's that. So whenever you're using an analog sensor like a photocell, something that's environmentally dependent, right? Because this would be different if I had this light off on my circuit all the time, right? Or I was in a different room or whatever, then you want to do some sort of calibration. It's also just helpful when you know that you don't have that full range of information, but you want to take advantage of it. So, after this, what I'm going to do is I'm going to show you some color mixing and color fading using your RGB LED. And that'll kind of wrap things up for the analog stuff. There's a whole bunch of sensors out there. We talked about some in class. Hopefully you find something. These are really fun to play with. The photocells are really fun to play with. You can make a lot of weird stuff with them. Try it out, see what works. Have fun with it.